We've been working through some energy conservation laws and stuff like that. So what I want you to first do is starting with bell work. Write something down, jot your initial thought. Maybe we will expand on it throughout our lab. And while you guys are doing that, I'm just going to briefly go over our objectives for today, what we're trying to accomplish. We're going to do a lab, and it's all inquiry-based, so hopefully you guys can work through your own question, and you get to design an experiment and record data and draw some conclusions at the end of the class. Okay, so I'll give you a couple more seconds to wrap up your bell work. Then the pencil is down, and I'll know you're done. Okay, so what we need to do first off is split in groups. So how about Jamie and Katie work together and Alicia and Christy work together? And I want you to take out some notebook paper, okay? And then what I want you to do as a group is come up and make some observations on this lamp up here. We're going to make 2 rounds of observations. Use your senses. Disregard the fact that it wobbles, and that's just because I break things.
Can we turn it on?
We can after you guys observe the ball off. Stay up here. We have a second round of observations. You guys write anything down? Yep. What did you get? 60 watt. It's cold. It's cold, okay. Good stuff.
It's plugged in.
Alright. So now write some observations. Use your senses, but don't harm yourself.
Oh, I'm getting blinded by the light. Blinded. I'm writing out a step. Still white. It's much hotter. And it's still
What did you guys observe?
It's hot.
It's hot?
It blinded me.
It blinded you?
so nice.
Alright, so let's as a group let's talk about our observations. Hit me up with things you noticed differently, maybe between your first round of observations and your second round. Ms. Brubaker?
There was a temperature change?
There was a temperature change? Absolutely. What else did you guys find?
He said it went from being like blue to yellowish glowing.
Right. Okay. Why?
Producing light.
Absolutely. Let's talk about your temperature change idea, because that's a really good thought. Why did the temperature change?
It's creating electricity.
Okay. Why is electricity producing heat? Okay, so let's think about this. What is the purpose of my light over here? You can tell me.
The
This
purpose?
Yeah, what do I want this light for?
Make light. So,
Right.
Yeah.
So when I'm grading your assignments at night, I don't lose my eyesight, okay? So the purpose is to produce to produce light. So since this appliance's main purpose is to produce light, any energy that is given off as heat is what?
Wasted.
Wasted. Why?
Because that's not what we're using it for.
Right, that's not the function of the appliance.
Right.
Okay? So if our light was perfect at producing light, Jamie, what do you think the energy input would equal as energy output, as light output?
The same.
The same? Okay. So how much energy is coming in?
I don't know.
Like say 100%. If 100% energy is coming in to function this light bulb, Jamie, how much do you think, if it's perfect at being light, would the output be? How much light?
None.
No, 100%, right? Think we have energy coming in. If it's efficient, then the energy coming in is going to have 100% light output. Does that make sense?
Heat.
Okay. But what makes, let's talk about heat a little bit. What makes it produce heat?
Energy.
The energy, which means, like, let's think about our bell work.
Lack of efficiency.
Lack of efficiency, perfect. So, today, we are going to take that concept of efficiency and energy, and we're going to measure, and we're going to test and experiment. But what I want you guys to do first in your groups is I'd like you to come up, and I'd like you to take a list of materials that you have here, and I want you to write down all the materials that you have, and then with your group, I want you to write a procedure, okay? But after we do our materials first, so when I say go, you can come up and write down all your materials, and then we're going to come back as a class, and we're going to think about what we can possibly test, what our question is to test, okay? So go.
Ready to go.
And if you don't know what something's called, or you're not sure what it is, let's capture that on the board so we can work through our vocabulary to make sure we know the proper definitions of things.
I don't know how to spell styrofoam.
S-T-Y.
Right, that's styrofoam? I don't really know what it is.
I don't know. We'll find out.
Light bulb, which is 40 watts? That says 40, I don't really know. Oh, this you would hook your, this looks like you'd hook this too. I don't know what it's called though.
Oh, we'll write that too. What?
And then we have our teeth. A thermometer.
Materials.
Oh.
Yeah, that was stopwatch.
Did you guys get your list of materials all done?
Yep.
Okay, awesome. So I see that we have some questions as to what things are. So let's go ahead and work through what materials you guys have listed as a class. Susan wants to share some.
We have batteries.
Batteries, okay.
Light bulb.
A light bulb. What else?
Insulation.
Insulation. Perfect. Now, Christy
Oh, is that?
was confused about what this styrofoam circle
So that's
was,
insulation.
right?
Yeah.
Now, what else do you guys see here?
Coil.
Coil?
Is that the? Which one is the coil?
I thought it was
Is
a little round metal.
coil? Is that the bulb holder?
So this thing is what we're confused about. We don't know what this is.
We know what it does, we don't know what it means.
Okay, so when you are changing a light bulb, what do you say? You're going to put the light bulb in the what?
Fixture.
Fixture. Socket.
Oh.
Awesome. So we just have to think on like a small scale here. This is our little socket for our light
Leave
bulb.
it to me. I don't
Oh.
change the light bulbs at home.
What else do you guys have? What else? What other materials do we have?
Stopwatch.
Stopwatch, okay.
A thermometer.
Thermometer, okay. Anything else?
Container.
Oh.
Plastic container.
Plastic containers. Does anybody know what this is called? This is a hot plate. So we'll add that to our working vocabulary. And what else?
Water.
Water, okay. And anything else?
Wires.
Wires. What are these called? name of these? What are these called? I know you guys
Positive and negative teeth.
teeth.
Yeah.
They're sometimes referred to as, have you guys ever heard alligator clips or leaves?
Yes.
Yes. Okay. Alright, so seeing all of the materials that you guys have laid out, I want to work through this as a class, and I want you guys to come up with a question, like what can we test? What is our question? What are we trying to solve? We talked about light producing heat and light producing light. So does anybody have any ideas what we, Christy, you're on fire.
How much energy our light bulb is giving off
Okay.
in relation to how much light it's giving off.
Okay.
So how efficient it would be.
So we ultimately want to test the efficiency of this light, right? So we can't just boom measure efficiency, right? So what are we going to have to test? You guys have a list of your materials, thermometers. What are we going to have to measure to really find our efficiency?
The heat.
Yeah, perfect. So maybe our question could be, does our light produce more light or more heat? And then we can work through those calculations, which will happen tomorrow, and really determine if our light bulb is efficient. Okay? So as a group, you guys work as a group, it doesn't have to be as a class, and determine what your hypothesis is going to be based on our question. And then I want you to write that down. You guys almost done with your hypothesis?
Yep.
Okay, Jamie, what's your group's hypothesis?
The light will produce more heat than light.
More heat than light, okay? Christy, what about your group?
That is also our group's hypothesis,
Okay.
meaning that it'll be inefficient.
Okay, perfect. So now as a group, I want you to write down a procedure that you come up with using the materials that you have already laid out. Everything on your material list will need to be used, so you can take that into account. And then before we'll start, I'll have you guys get it approved by me. Yes,
Can I
Christy?
see the hot plate again?
Absolutely. Yes. And you guys can come up and take your materials so you guys can work through your procedure if you need your materials on hand.
Miss McCollum, she won't help me.
She won't help you. Well, let me see if I can help you guys. What are we struggling with?
How to start this.
How to start this, okay? So what's your hypothesis? Produce more heat than light. Let's go up and grab our materials, and then we'll see what we have and logic our way through it.
What do you?
Jamie, come on, help. Oh, right. You know, we have daily participation points, so I would hate for...
Well, I can get a 0.
You can get a 0? I think it would be good if you'd help, so how about you come up here? Okay? Then, do me a favor, Jamie, tell me what my expectations are. Will you look up there and read them for the class, please?
Listen to directions the first time. Respect if you use something, put it back. Absolutely no use of shop equipment without the teacher consent and supervision, and arrive on time. Come prepared. Create a positive learning environment.
All right, so are we creating a positive learning environment with bad attitudes?
It's just not my day.
Just not your day? Okay. Well, let's see if we can work through it here. All right. So what do we think our first step's going to be?
The light bulb in the socket.
Okay.
Oh, I didn't get an installation.
I mean, I don't know. But how else would we heat the phone?
Don't. That's going to hurt my ear. Give me that.
What time you go?
How are you guys making out over here? Done? Okay. Procedure. Good. You have your hypothesis written. You're gonna put water on the hot plate. Why do
Oh, we
you?
forgot our insulation.
Okay. Now, do you have a reason as to why you're putting
I'm
water
gonna go grab our.
in the hot plate?
Well, you want to know the
Thinking.
change in temperature.
Okay.
So if you have water.
What is this?
Oh, that's our thermometer.
Yep, we.
Sorry. We need to get these photos.
We need the alligator teeth. Well, should we compare? Are all these light bulbs the same size?
Yes, they are. 7.5 watts.
Okay.
But that would be interesting if they weren't the same, right?
Yeah, because then we can compare.
And we could test to see which light bulb would be more efficient.
Do you have a thermometer? Over there?
Yeah.
Alright, so what did you?
So, everything is looking really good. You have put water on the hot plate.
Okay.
No.
Well, I'm thinking put it in here
Okay, why would we,
and then put your light bulb in it to see how hot it gets.
what's the benefit of using water versus air?
Water's conductor of heat.
So let's
Transfers
think-
better in water than
Right.
it is.
So let's think about this though. If we put our thermometer in here
What are you doing?
and you have your light over on this side.
Oh, so you're gonna insulate,
Right.
so then the heat can't escape.
Yeah, the heat can't escape and,
Well, then how's my light bulb gonna? Does it fit?
yeah. But I want you to understand that if you measure with air, you're only going to get the heat coming from this side of the light bulb. And the water in there is, like Alicia said, it's going to retain that heat and you're going to get the true measure of, it's going to be a more accurate measurement.
Okay,
Okay?
so can we go ahead?
How much water are you guys going to use?
Can we fill the whole thing?
Okay,
Or do we need, we probably need an actual measurement. Can we use the measure? Oh, there's one. We didn't write that on the materials sheet.
how are you guys making out in this group?
I think I can.
Good.
Okay.
Should we put the like?
So we use, can I see the water? Can we just use 1 fluid ounce?
I would shoot for
Half a fluid ounce?
filling it up to this line because you don't. You want this to sit in. You don't want the water
But
to
wouldn't
get too
1
full.
be used?
Yeah, if you
That'd
think,
be easier to calculate.
if you want to use
But I
that.
think that's too much.
If you put it in and you know the amount and you pour it in, whatever, into like a subtraction time.
Maybe there is 1 fluid ounce. I just think 1 would be. Oh no. Oh no. Oh wait, we got it.
Miss McCollum, can you check our procedures so we can do
Absolutely.
this?
Yes, I'll be right over. I went to Alicia and Christy's group. I think we should reevaluate our water level. Okay,
Sorry.
what are you looking at? It
Okay,
needs the
let's
battery.
try this again. What's it have?
Needs a half fluid ounce of water. Good. You're using measurements. Now, why is it important to use a measurement there?
We'll
There's
probably
the-
need it to calculate stuff
Yeah.
tomorrow.
You want to, in experiments, you want to keep as many things as consistent as possible. So if you do this
Yeah,
experiment
that's
again,
not it.
you're going to use the same amount.
Okay, so let's do this.
Do the initial temp.
Yeah. So
I
we're
think
gonna
that
have to
looks pretty
type this.
fantastic.
But
Awesome.
you want to do it like this.
See if I can really spill this.
Oh, and here
Are
we
you,
go again.
one more thing. When are you going to, what's your first temperature measurement going to be?
At 0.
Zero. Got it.
It's okay. I got
You're
it.
just going to be a little careful because what do we know about electricity and water?
Yeah,
It's
it's a bad thing.
It's a bad thing.
That's about 70.
So the
That sounds too, feels too cold for that.
guys using Fahrenheit or Celsius?
Fahrenheit.
You think that's the best one to use?
That's fine.
What are you using
So we
chemistry
have a
class?
paper towel, or is there a place?
Celsius.
Celsius? Why?
Because that's what everyone
Don't put it
uses.
in next
That's
to
the
3 foot.
International unit.
International, yeah.
Perfect.
That's what I use.
What's holding them on?
We're just gonna stop because I'm out of time, but what I would do is let you guys run through the experiment because you all have like good procedures. You would capture your data and then we would wrap up, and the following day we would go through like energy calculations, output, input, and determine how efficient our light bulbs are, and then we would make that connection to, you know, light bulbs we use on a daily basis and how we can maybe conserve energy in our daily lives. Yeah.